What's going on, people? It is Boom or Bust episode 7, the show where you submit tiny subwoofer designs, I 3D print them, and we throw them head to head to see whose is the loudest. Now, in today's episode, we have our first true quarter wave design. I don't really count the half-wicked one as a quarter wave because for the most part, it's acting like a fourth order bandpass, but Justin was kind enough to send in this design for this very basic T-line. This is about as basic as you can get for a T-line. It has a constant line width throughout. The line area actually looks a little bit bigger than the cone, the piston area here. If you look on kind of basic T-line 101s, generally people tend to advise you keep the line area about the same area as the piston area. I could be wrong, but that's what I've generally tended to read over the years. So this is essentially just a tube mounted to the driver, folded around into this kind of more square shape. The length of this tube defines the lowest note it will play, which is based on the quarter wavelength of the length of the line. The length of the line that Justin submitted is 45 centimeters long. Now we times that by 4 to get the full wavelength, which is 180 centimeters, which gives us a wavelength of 190 hertz. So the lowest frequency that this is going to really resonate at or play is 190 hertz, which in our scaling works out at about 31 hertz. So that's actually quite a nice lowest frequency for a lot of kind of systems, applications and music. However, for our test, we do require that the system plays down with some decent potency to 25 hertz because people love them lows, don't they? So I was trying to get boxes that really did cover the lowest to the highest that people want to play. But I mean, 31 hertz, that's pretty standard procedure, even slightly low for some people in some parts of the world. Now, I believe that with T-lines, the sharpness of the roll-off and the way that the woofer unloads below the lowest fundamental it will play is actually quite steep and quite sharp. So I don't know whether this will do the 25 scaled hertz very well, which is 150 hertz, but we'll have to wait and see how it comes out. Now, interestingly, I actually have 2 of these boxes, not by choice. This was the first attempt print I did, and something went wrong with the print settings or the printer. It under extruded heavily, and the walls were not adhered to each other in the slightest. So if I ran this, it would just get a load of buzzing, probably loads of lost pressure. It would just be an absolute disaster. Wouldn't really showcase what this box is capable of. So I had to print it again once I sorted out my print settings, but I do now have kind of 2 of these, and it would be cool if I could somehow get this one fixed where the walls were adhered, maybe like some really thin adhesive that I could dunk this in and then open all these up to get the adhesive to go between the walls, let it set, and then I could have a nice pair of T-line bookshelf speakers perhaps. That might be quite nice rather than just wasting this one. But I'm using the lid from this one because I thought there was no point printing another lid, seeing as the lid was actually fully sealed up against the glass build plate. So the lid is from the original print and the rest of the box is from the reprint. But yeah, I think the first thing to do is to whack this on the Dayton DATS V2 and see whether my prediction, my measurement of 190 hertz lowest fundamental is correct for the quarter wave, and also give you guys an insight as to what an impedance graph looks like for a T-line rather than a Helmholtz resonator, which is pretty much all we've had so far. Now, at first glance, this might look a bit similar to some of the impedance sweeps we've seen from our ported boxes. However, it is different. Unlike a ported box, which will have one main frequency that the port holds onto the cone, transferring energy that the cone is creating into displacement out of the port, a T-line will have multiple modes up the bandwidth that hold on to the cone, then let go, then hold on, then let go as we go up the frequency range. So if we take a look at this graph, we can see that the first impedance spike is just completely unloaded. That's just where the woofer is happily moving freely. The line isn't really affecting the woofer's excursion here at 96 hertz. And above 96 hertz, we start getting to the first mode of this box, which I predicted by measuring the line length with the tape measure at 187.1 hertz. So that is the lowest fundamental. That's the lowest note that this box is going to happily play, because that is the lowest note that this line is going to resonate at. Above this frequency, we see that the line starts to let go again of the driver, giving the cone lots of excursion up to a peak of 238 hertz. So that's going to be where the woofer is moving a lot because the line is now not loading the cone anymore. So you're now listening to air displaced by mainly the cone only. And then after that, we come back down again and the line starts loading the driver once again. all the way up to 620 hertz here. So that is another mode of this line where the line will take over from the cone and you'll be listening to a bit of air displacement from the line. Now obviously that gets less and less as you go up the frequency range, but that's essentially how a T-line is working. It grabs hold of the cone at first during the first fundamental tuning frequency of the line, then in between modes it will let go, let the driver move a lot, and then hold on again as it approaches the next mode of the line. Now sometimes a T-line box that you'll see online might have a Helmholtz resonance as well, like it might act like a ported enclosure at some specific frequencies, and this tends to happen with T-line boxes that have a compression chamber first behind the driver before the line starts, where there's like a change in area, so the driver will have like a bit of a volume behind it, then the line starts, and that's because that will then set up a Helmholtz resonator where you've got the volume of air and then a length of what then becomes port. And usually it becomes a very low tune long port because it's mostly designed to act as a quarter wave resonator, so it's usually pretty long, but you can use that to your benefit if you're wanting to design something that's really flat or that has like a specific peak where you want it. You can design a T-line that also has a kind of ported box mode. You can kind of calibrate that Helmholtz mode to be where you want it, maybe to fill a null in your response from the T-line, or maybe to boost a frequency range that you really like, maybe to play a bit lower, play a bit higher than it otherwise would. Okay, but enough of that. I want to have a listen to how this sounds, just in the room here, open on the table, to get an idea as to whether I don't think there's going to be any noise, like not like we had with the neuter shooter or we had with the barrel of bass here. There shouldn't really be any chuffing noises or anything like that. It should be quite a pleasant, clean sound to the ear, but it may very well prove me wrong. So let's plug it into the amp and have a quick listen to how it sounds open here. So let's play 150 hertz first, which is, like I say, it's a bit below the line resonance, the lowest frequency this will resonate at. So it might have a few harmonics on top of it, but let's have a quick listen. That sounds pretty clean so far. Not bad. Yeah, as we increase the volume, there does become this wah, as we've seen before in a couple of other enclosures. And as we go nearer to the mechanical excursion limit of this driver past Xmax, yeah, you can hear the distortions creep in. And that's partly just due to the low Xmax of this driver. If it had a higher Xmax with the same mechanical excursion limit, it would actually sound cleaner for longer. But yeah, compared to the neuter shooter and the barrel of bass, it's extremely clean sounding down there. So 198 is pretty much bang on the bottom mode of this line. So let's see how this sounds. It should be very clean. Oh my god. This is getting loud. The driver hasn't even visibly moved yet for me, like as far as my eyes are concerned. It's completely stationary. Oh my god, the amount of load that this box has on the driver at that frequency is monstrous. If I wasn't limited on power, I could probably throw 200 watts, like real 200 watts at this driver, and it wouldn't reach any excursion limits, and it would be monstrously loud. Now the next frequency up, 270 hertz, was on the downward slope from the second impedance spike, so we should get a bit of movement on the driver here. Yeah, a bit of movement, but not mountains of it. Like, it's actually still very controlled. What I've noticed with this driver is at the higher frequencies, as you turn it up, the cone kind of pushes out and finds an outward center of oscillation rather than staying in the middle. But that's not really happening here, so we are getting some good control of the cone here. And then the 60 scaled hertz, which is 360. Again, pretty good cone control on that one as well, and it's reasonably loud. It sounds nice and clean. This is actually, yeah, probably the best sounding enclosure. I didn't do this test with the half wicked one, so I'm not sure how that one sounded out on the table here, but this sounds very nice. Let's have a quick look on the REW and to see whether the waveforms match up with what I'm hearing. Yeah, so although this isn't the most perfect looking sine wave, it's a lot nicer than the last two ported boxes we've done, although they've been far from perfect designs. It doesn't start getting really misshapen with that 300 hertz harmonic coming in until the driver really starts reaching its mechanical limit, you know, way past Xmax where the BL is no longer linear. So that's just a thing with the driver rather than the enclosure per se. But kicking it up to 198 hertz, which is the lowest frequency this line wants to play, shows us that when the cone is held still and not allowed to give any distortion, proportions, the line rings clean. This is a beautiful looking sine wave and it's very loud. It goes off the screen here a little bit. Very nice indeed. And the same trend continues upwards with the 270 Hz looking beautiful, as does the 360 Hz. So yeah, in absence of any chuffing from ports or weird ringing or harmonics going on inside the enclosure due to different volume sizes, a basic T-line seems like it sounds lovely and clean, provided you stay above the lowest note that it wants to play. One interesting observation I made was when I played 198 Hz on the RTA, you can see here that the 600 Hz harmonic is louder than the 400 Hz harmonic, which I am not used to seeing. Usually the presence of each harmonic seems to get quieter as you go up the frequency band, but here it's not the case. Now, I don't really have an explanation for that, not quite sure what would cause that, so feel free to educate me in the comments if you've got any ideas. I'm wondering whether it's got anything to do with there actually being an impedance peak here, pretty much just above 600 Hz on the DATS graph. So that shows that the line wants to kind of resonate there a little bit more than 400 Hz at least, so that's why that harmonic rings a bit louder than the 400 Hz one, just because that is a natural mode of this enclosure anyway. So yeah, that was really interesting. But now it's time for something fun. Let's get the enclosure into the test cabin and see how it sounds on some music demos. For the demos, so you can see the driver moving as the music's playing, I'm going to have the box mounted with the woofer and port exit upwards so we can see it all moving nicely. When it comes to doing the dB test, I'll figure out which is the loudest. I think probably firing towards the back of the cabin against the wall is going to be loudest. But for the demos, let's fire it up and have a look at the woofer moving as we listen. Yo, not even joking, the SPL sensor just fell off. guys, but that seemed really loud. I want to say that seemed like the loudest one that I've tested so far. For demos, it's hard to gauge because it's been a while since I tested the louder ones like the Half Wicked one and Ported and stuff like that, but to me that seemed insane. The amount of air that it was displacing from the open doorway here, the fact that the SPL sensor freaking fell off, the whole room was like, it just seemed really freaking loud. So let's find out once and for all, is this as loud as it seemed when on the meter? We can get the meter back in where it's supposed to be. And in terms of orientation, I'm not sure. I mean, it was performing freaking crazy like this, pointing upwards. I'm going to try pointing up and pointing back. Whichever one was loudest across a range of frequencies on the SPR meter, I'll go with that one. And as always, we're going to be testing first with the door open. I'll remove this small piece of single ply toilet paper from the door there so it doesn't interfere with the test by any means. And let's get testing. Okay, whoo, boy, am I ever excited for this one. Door open, 25 scaled hertz being a 150. This is where the box is slightly unloaded, so we're going to see whether the Helm Holtz mode can actually help out a bit and get this up to where it should be. Let's go. Let's see what it's doing. 15.2 there on the watt meter and a 140.4. Okay, now this isn't the loudest that we've ever seen at that 25 scaled hertz, but this is unloaded. This is ridiculously loud considering that it is outside of technically what this box should be able to really play. It's louder than the ported boxes that were kind of tuned down there. So wow, excellent stuff. I suspect we're going to see a trend here with the next frequency. We should be as loud as, or if not louder, at 33 scaled hertz being a 198. I can already tell it's ridiculous. 134 already. It's not even registering. It's not even registering any power yet, and we're already at 134. That's 1.5 watts now. .2 and a 140.7. Okay, interesting. Sounded a lot louder to my ears. I was expecting to look up and it say like a 148 or something, but that is nice and flat. 140.7. Wow, 2 scores above a 140. I can already see this working its way to the throne on boom status. Now let's try the next frequency up. Provided it can maintain above 130s, it should solidify its top spot. 15.4 and a 133.8. Yeah, this is looking pretty promising. And lastly, 60 scaled hertz being a 360. 15.2 and a 131.7. So yeah, above 130 across the range with 2 scores in the 140s. Wow. All right, let's close off that cabin door, see what it's doing with the cabin completely sealed off. I suspect the 25 scaled hertz will drop quite considerably, but hopefully the rest of them will pick it back up again. 15.4 on the watt meter there and a 128.6. 15.4 and a 138 dead on the nose. Wow, 138 with the door sealed. Could be wrong, but I think that might be the loudest we've had so far with the door sealed across the range. 15.7 and a 129.2. Jesus, I mean, in person that sounded ridiculously loud, but a 127.1. So, where does that place us on the leaderboard? Drum roll, please. With the door open, we have a 136.65 dB average, and with the door closed, a 130.73 dB average, placing the Justin transmission line in second place, above the Derek V5 by about a dB, but 3 to 4 dBs off of the Half Wicked one. I was honestly not expecting that. When I was demoing this and testing it, I was like, damn man, this thing's freaking loud. But I'd obviously forgotten just how loud the Half Wicked one was. It's been a little while since we tested this one. It was the third enclosure to get tested. And yeah, I guess we've had some slightly quieter ones in between, and I was a bit taken aback by how loud the T-Line was. But yeah, the Half Wicked one still definitely very comfortable on its throne in first place, 3 to 4 dBs above the rest. Now, one of the benefits of a T-Line is that it can continues to play up the range, maybe a little nicer than a ported box would do. So I think that with this T-line, if it was tuned a little lower, if we were able to bring up that 25 scaled hertz to the level of the half wicked one, like 145 dBs on the meter, then the other frequencies above that wouldn't get hurt too badly, and it might actually be able to match or maybe outperform the half wicked one in this test. I think that being tuned at sort of 30 scaled hertz is great for everyday listening, most musics and stuff, but in this test, in this environment, in this competition, lots of people love playing lows down to 25 hertz, so I wanted to see if we can design an enclosure together that is the best at playing a whole range right down to those lower stuff that a lot of people love to play. And although the T-line definitely is capable of doing that, still with a reasonably loud volume, it is nowhere near the capabilities of the half wicked one, and then this still has the ability to play up the range as well, so pretty crazy stuff. The submissions are still rolling in very healthily. I've got loads to go through, and as a result of that, I'm going to be trying to make this series twice a week. Trying my best. I'm going to see what I can do, but I'll try and make it twice a week so we can get through as many of these submissions as we can, nice and quickly. I'm going to combine certain submissions into shootout. So for example, the standard ported, L-ported style boxes, or 4th orders or 6th orders where I've got like 3 or 4 of them, I'll combine them into one episode in like a shootout form. So I'm just kind of working on that at the minute to try and see how that's going to look. And to my delight, there have been more quarter wave based enclosures submitted, namely we've got some horns as well, and also some Paraflex designs, which I'm very excited to do, so look out for those in future episodes. If you think you can design an enclosure here to top the half wicked one, then by all means send in a design. There is a link in the video description to instructions that cover all of the details you need, TS parameters of the driver, size of this cabin, everything you need to design an enclosure for this series. If you're interested in sponsoring this series by some means, maybe a branded sticker on the test cabin here, or a sponsored message or segment in one of these episodes, then feel free to get in touch. Link in the description to an email address as well. But yeah, hope you're enjoying the series, and I'll see you in the next one. Take it easy, guys.